E-commerce photography required booking studios, coordinating logistics, and spending $300 per product shot. Today, that physical process is replaceable by a 21-cent API call. Historically, AI image generation failed in commercial settings because it could not render text accurately, and it lacked a mechanism to maintain product continuity across a full catalog. OpenAI released GPT Image 2 on April 21, 2026, to address these specific technical bottlenecks. The model currently holds a 242-point lead on the Image Arena leaderboard, supporting 99% text accuracy across 7 scripts and native 16 image reference arrays. This model functions as a production-grade asset engine, manufacturing print-ready and web-ready visuals directly from structured data. Visual asset production has transitioned from a creative bottleneck into a software engineering problem. Operating at this threshold alters the margin structure of direct-to-consumer retail, allowing for high-fidelity branding at near-zero marginal cost. You must construct a bifurcated architecture to deploy this system. This deliberately separates the logic layer, where you define the brand, from the programmatic layer, where you generate the volume. Relying on standard chat prompts to maintain brand constraints will fail. The model's interpretation of loose adjectives like modern or soft drifts over time. Instead, you establish a central logic node by uploading a strictly formatted brand specification document to a custom GPT. It functions as a persistent knowledge base, explicitly defining the hex codes, font stacks, and photography recipes the model must reference for every request. This setup requires regular auditing. Every 50 generations, you check the output against your specifications and tighten the brand spec file to correct any aesthetic drift. This protocol transforms a generic chat window into a localized logic engine that enforces brand laws through a structured knowledge base. The primary technical challenge for e-commerce is maintaining multivariant consistency across a large catalog. You solve this by utilizing 16 image reference arrays and a character anchor pattern. The model does not average these images. It processes the array as a coordinated mathematical system, extracting discrete traits like fabric texture or light temperature from specific inputs. This node graph shows a central source image connecting to satellite nodes for lighting, style, color, and composition. By locking the background and camera variables, you isolate the target product, allowing the system to change only the color to your specified hex code. Explicit indexing in the prompt payload is required. You must tell the model exactly which visual trait to pull from which reference image index to avoid muddy generation. This level of control allows you to apply an identical lighting setup to every variant, mimicking a controlled physical photo studio. You apply the same anchor logic to humans, ensuring a recurring model maintains the same facial features and wardrobe across different environments. This systemic control eliminates aesthetic drift across the entire brand catalog. Beyond product shots, the system scales to generate marketing collateral that relies on precise data. The platform natively renders text inside images with 99% accuracy. It supports complex mixed script layouts, allowing for English titles to sit cleanly alongside Japanese subtitle text. To achieve this, you must wrap all target text in verbatim quotation marks within your prompt. You must also include negative constraints, commanding the model to omit duplicate text and watermark-style artifacts. This chart shows a sustainability standards infographic generated in a single pass. Text blocks outlining organic cotton and recycled polyester are sharp and perfectly legible. Native text generation internalizes the production of trust-building graphics, removing traditional design bottlenecks. To scale across an entire catalog, the workflow must move to the programmatic throughput layer. This requires building a GraphQL pipeline to interface directly with the Shopify backend. Passing binary image data directly through an application server creates a severe bottleneck and often leads to request timeouts. The correct architecture uses a staged upload flow. Step 1 executes the staged uploads create mutation, receiving a temporary URL and authentication payload. You are then pushing the file directly to a Google Cloud storage bucket rather than through your own server. You must append the form data parameters in the exact order returned by the server, or the upload will be rejected. Step 2 is executing the file create mutation to register the asset onto the Shopify CDN. Because this process is asynchronous, your application must pull the file status endpoint until the image is ready for use. Adopting this staged upload protocol allows for the reliable injection of synthetic assets at a massive production scale. Managing the financial viability of this pipeline requires an understanding of token unit economics. A high-resolution output costs roughly 21 cents. Refreshing a catalog of 50 products with 5 variants each costs $52, replacing a $15,000 photography budget. You can reduce this further. Reusing reference inputs triggers a 75% discount on cache tokens. You engineer bulk generation loops to maximize these cache hits across hundreds of consecutive calls. Optimizing these mechanics results in near-zero marginal costs for infinite visual iterations. From brand specification to GraphQL ingestion, the entire visual supply chain is digitized. This autonomous system generates results overnight that previously required weeks of agency coordination. Sustainable competitive advantage relies on architectural rigor. The brand's competitive moat is built on the precision of its AI pipeline and the integrity of its systemic data. Mastering this bifurcated structure transforms a standard storefront into an autonomous, highly profitable brand entity.